Welcome to our lecture number 6. Again, this is Mathematics 164 Precalculus at New Jersey City University. We are going to cover factoring, factoring part 1. Here we're going to learn how to factor polynomial expressions. So factoring, again, that's our lecture number 6, part 1. So first we start with the common factors. The common factor concept is that we have two terms. Here we have AB plus AC. So we're going to find the common factor. The common factor here will be A because A is common in both two terms. So AB plus AC. I will use the distributive law. Take A out, then B plus C. So this is an example showing that A is a monomial factor of the polynomial AB plus AC. And normally we call this a common factors. Why is it called a common factors? Because we have two terms here and the common factor is A among the two terms. So let's try another example here. Let's say if I have 2x parenthesis A plus B minus 3y parenthesis A plus B. Now, here I can see that I have two terms because parenthesis is the same as multiplication, as we said earlier. So here I have 2s times A plus B minus 3y times A plus B. So the common factor here will be A plus B. So we bring A plus B outside. Then we have 2x minus 3y. So our answer will be A plus B, then 2s minus 3y. Again, we are doing a common factors at the moment. We're also going to do factoring by grouping and also how to factor trinomials. So this is a common factor concept is that we have more than one term. In this case, we have two terms. We are going to look for the common factor in both two terms. So A plus B is common among these two terms because we have 2x, A plus B, 3y, A plus B. Now, factoring by grouping, this is an example. We have 5x minus 5y plus bx minus by. Again, 5x minus 5y plus bx minus by. In this case, I can't do a common factor because I have four terms here, and there's no any factor that is common among all the four terms. But I can see that I have 5x minus 5y. There's a common factor here, which is 5. I have bx minus by. There's a common factor here, which is b. So in this case, we can factor by grouping. I'll group bs minus by, then bs and 5s minus 5y. So we are going to get 5s minus y. There's a plus here. Then b is common, s minus y. Now, the main rule here is that when I do factoring by grouping, when I factor the two groups here, I should get the same term in the parentheses here. So I have 5x minus y plus bs minus y. So in this case, we come back to a common factors now. I have two terms here, 5x minus y and bs minus y. So I can use the common factor here, which is what? S minus y. So our answer will be s minus y, then 5 plus b. Again, let's go back one more time. Grouping 5x minus 5y, bs minus by. There's no any common factors among all the four terms. But we saw bs minus by, there's a common factor. B and 5s minus 5y, there's also a common factor. So we factorize 5s minus y, then the b, s minus y. Now we have a common factor of s minus y, s minus y. So the final solution will be b plus 5x minus y. So b plus 5 and s minus y. Now let's go through the factor trinomial. We have two types. Now, if I have a trinomial with highest exponent 2 or degree 2, then there's a way that we can do it. What we're going to do here is that I'm going to find a factor of x squared, which will be s times x. Then I'm going to look for two values. When I multiply, I will get 6. When I combine them together, I'll get -7. And that's what they are explaining to us here. If I have s plus a times s plus b, we do the FOUL. S times x is s squared. Then let's do the outside. A, or the last term actually, let's do the house. A times b will be ab. So I have s squared and ab. Now, the inner and also the outside, which will be again a times x, then s times b. We're going to get positive. So here we can factorize it. We get a is as plus bs will be a plus bx. Why we write this in this form is that when you are doing trinomial, look how it works. I have s squared plus a plus bx plus ab, which means I'm going to convert this trinomial, factorize it to s plus a and s plus b. So I'll factorize x first. S squared is x and x. Then I'll look for two numbers. When I multiply, I'll get ab. When I combine, I'll get the same, the middle value, which is a plus b. So we can see here we have ab, then a plus b. So the same thing we are going to do in this example here. I'm going to factorize s, so I'll get s squared, I'll get x and x. I will look for two numbers. When I multiply, I'll get plus 6. And that will give me -6, -1. -6 times -1 is +6. Then when I combine it, yes, that's correct. -6, -1. When we combine, we get -7. So that we are using this formula here, or the techniques here. So we can see our answer here. S squared plus a plus bx plus ab. So this is the solution we are looking for. So final solution we said is -7. Means if I use -1 and -6, I'll get -7. And if I multiply -1 and -6, I'll get +6. So that meets our term here. So our final answer will be s minus 1 times s minus 6. Again, trinomial with only the coefficient here is 1, s squared is 1. There's another technique which we will come to that next. If we have any value here more than 1, other than 1, like 3, 7, any value, then we use different techniques altogether. So here, factorize x squared, which will give me s times x. Look for two numbers. When you multiply, you get +6, which will give me -6 and -1. But the same two numbers, when I combine, I should get -7. Okay, so -6, -1 is good, because -6, -1 will give me +6. -6 combined with -1 will give me -7. Yeah, I know 3 times 2 also is 6. Now, if I use 3 times 2 is 6, +6, but 3 plus 2 is not -7, it's 5. So if I have x squared plus 5x plus 6, then I'll use 3 and 2. Because 3 times 2 will give me 6. 3 plus 2 is 5. So if I have plus 5x, then answer will be s plus 2 and then s plus 3. But you have -7, so I have to use -1 and -6, so that when I combine, I'll get -7. So we are saying that when we have other than 1, it's very straightforward. Now, when we have 9 or any value, but no one, then we are using different process, different techniques. So we saw if there's only 1 here, let's go back. S squared minus 7s plus 6. All we need to do, factorize s squared. which will give me s and x. Look for two numbers. When you multiply, you get 6. When you combine, you get the middle coefficient minus 7. But here we have 9. So the first thing we do is that multiply the first term with a constant value, which means the variable with the highest degree, which is 9s squared times 12. 9s squared times 12, I get 108x squared. Now, factorize 108x squared. When you factorize it with two terms, you want to get the middle value here, minus 31x. If you cannot get the middle value by factorizing 108x squared, then that means we can't use these techniques. We may try another techniques. If it doesn't work, then that means we cannot factorize. Sometimes we may have an equation that we cannot factorize it. I mean, a polynomial that we cannot factorize. It's possible. So again, one more step. 9s squared times 12. Take the last and the first expression, 108x squared. Now I want to factorize this and have only two terms. So I get minus 27x times minus 4x will give me positive 108x squared. We can choose many values. I can even choose 2 times what will be 154. 2 times 54 is 108. So 2x times 54x will give me 108x squared. But when I combine 54 and 2, I will not get negative 31. But negative times negative is positive. 27 times 4 is 108. S times S is S squared. Now, when I combine these two, I get negative 31s, which is my middle term. So this can be factorized. So we write it down. Now, instead of writing 9s squared minus 31s plus 12, I write down 9s squared. I'm using the two factors here now. So we use minus 27x minus 4x plus 12. Then here we can factor by grouping. So we get 9s squared minus 27x plus minus 4x plus 12. 9s is common here, we get s minus 3. 4 is common here, s minus 3. Then we combine it. So we get 9x minus 4 and s minus 3 because s minus 3 is the common term in the two terms left. So this is the step when we don't have 1 in the trinomial s squared. Here is 9. Normally we call this method AC method. Why is called AC method? Because we multiply the first term is A, the last term is C. Then when we get the solution, we find the two terms factors that will give us the middle value. Luckily, we were able to get it. Then we replace those two factors with the middle term, and we get this. Then we do the grouping, factorized by grouping. So this is another example. Again, we went through this in our previous lecture, which is lecture 5. This is a perfect square. So s squared plus 2as plus a squared is the same as s plus a all square. If you want to prove this, we can just multiply s plus a times s plus a, and that will give us s squared plus 2as plus a squared. The same thing, s squared minus 2ax plus a squared will be s minus a all squared. We can prove it by multiplying s minus a by s minus a. And that will give us s squared minus 2as plus a squared. The difference of two squares, s squared minus a squared will give me s plus a, then s minus a. To prove this, multiply s plus a with x minus a, you should get s squared minus a squared. So let's try the example using the difference of two squares. When I look at this expression, I can see that, oh, this is a difference of two squares. Why? Because 25 is the same as 5 squared. So I'll get 5x all squared. 36 also is the same as 6 squared. So I'll get 6y all squared. So if that's the case, then our solution will be what? Difference of 2 squared, 5x minus 6y, and 5x plus 6y. Now, let's say if this question should have been 20x squared minus 36y squared, we cannot use difference of 2 squares. Maybe we can use a common factor because 20, I think 4 can go into 20, and 4 also can go into 36, so we can take 4 out. And that's the only solution, the only way we can solve this problem. So again, this is difference of 2 squared because we can see 25 is the same as 5 squared. So we get 5x squared minus 36 is 6 squared. So we get 6y all squared. So we get 5x minus 6y, 5x plus 6y. So here we say that these two factors are called binomial conjugates because they differ in only one sign. If I have 5x minus 6y, 5x plus 6y is called binomial conjugate because both of them have the same term, but the difference is that one is negative and one is positive here. So there's a guideline for factoring completely. What we mean by completely is that sometimes we may have a question, and the first thing we have to do maybe is to take the common factor out. Then it will remain either trinomial. If it's a trinomial, maybe we can factorize it also. Or we have difference of 2 squares. We can find the difference of 2 squares before, if there's any factorials we have to do, then we do it. So that's why they said, guideline for factorial completely, always we look for the common monomial factors first. Then difference of 2 squares, if the expression is binomial. Otherwise, if it's a trinomial, then we do our trinomial squares or other method of factoring trinomials, also factoring by grouping. But normally, always we have to look for the common monomial factors first. So this is an example. I have 12x squared minus 36x plus 27. When I look at this question, I can see that 3 is common because 3 can go into 12. No remainder. 3 can go into 36. No remainder. 3 can go into 27. No remainder. So my common factor will be 3. And that's what we have here. When I take 3 out, 3 can go into 12. 12 is 4. So we get 4. Sorry, there's a square supposed to be here. We miss the square. Because we can see the question we have 12x squared, not 12x. Otherwise, we combine the two. So this is supposed to be squared. So we have 4x squared minus 12x plus 9. Because again, 3 can go into 12, 4. 3 can go into 36, 12. 3 can go into 27, 9. Now from here, we have what? A trinomial now. But with the leading term is not 1. So we can use the AC method here now. After using the AC, actually this is a perfect square because we can see that we have 2x all square. Then 9 will be 3 square. Then remember we say 2 all square. So which means we have the term here 2x. So 2x times 2 times 3 will give me 12x. So this is a perfect square. We change it into a perfect square format. If I have a minus b is the same as a squared minus 2ab plus b squared. So here our b is 3 because it's 9, 3 squared. Our a is 2x because it's 4x squared. So it's 2x all squared. So I get my 2x, which is a minus 3 because b, a minus b all squared. So this will be our final solution. Then the second one, the same thing. We have 16x squared minus 64y squared. Okay, the common factor here locally is 16. Because 16 can go into 64 4 times. So take the 16 out. 16 can go into 16 is 1, so it's only s squared left. 16 can go into 64 is 4, so we have 4y squared. Then when we look inside the parentheses, we have a difference of 2 squares because it will be s squared minus 2y all squared. And that will give me 16 s plus 2y and then s minus 2y using the difference of 2 squares. We have another question here. Factoring the differences of 2 squares immediately will be given as following, which is not factored completely because we could still factor 4 out. Because if I factor it 4s plus 8y, 4s minus 8y, we can see that 4 is common here. 4 is common here also. 4 will give me 2 and 1. So again, this will be the conclusion of part 1 of lecture number 6. And again, wish everybody the best. Thank you.